Hello. So the second talk also will be a technical one, a bit connected to TypeScript. You might want to really use TypeScript also with React, but you maybe are wondering if you should stay if you're not a React fan or you have no clue even what this is about. So should you stay or go grab a, I don't know if beer is possible, but water. So in few minutes you will see some really cool React stuff. With that also nice, clean, of course, code. And after this 45 minutes, you will gain so cool coding skills that you can impress your friends later. So grab a chair, like Jason here, and listen. So what will be the topic in the next 45 minutes, or hopefully a bit less? There's this keyword in the topic render. So I was wondering, and this is a topic, if this render keyword does mean the same for everyone or not, especially in context of React. Additionally, how to get from user interaction to one of the meaning of this render, DOM rendering, and then a bunch of fancy keywords like reconciliation, fiber, bailout. Hopefully, you will later know what those mean if you do not now. A few words about me. I'm Marcin, front-end engineer, and I'm from here, around Wrocław. I work at the company called Unique, and I'm looking for new ways to improve my skills. So partially also this talk. You can find me on GitHub and Twitter. On Twitter, I have 2 friends, and that's why I can mention them by name. Next year, there won't be displays or such a slide, and 2 tweets. So a bit of why this talk. So when you code for a while, there's higher and higher expectations of you. So in order to meet those expectations, you really need to know what you're doing. So when you're starting, everyone is not expecting a lot, but then after like 5 years, expectations are pretty high. So knowing your tools, your like daily tools you work with for like 8 hours at least a day, it's for me the key to success. And the second, maybe like idealistic thing, but I really like to think that I would like to make projects in a way that after a year, if I, for example, quit my company, someone will take my place and will be able to say, oh, this guy did a really good job. Let's move on. Now, the main part. If you know why, the main part, what exactly are those tools for probably many of us right now. Looking at the advertisements here from the sponsors, almost everyone looks for some reason for a React developer. So I was wondering what focus should be for me or someone who would like to start learning React. So just go to their homepage and read the first sentence. It's a library for building user interfaces. So it probably won't solve all our problems. So if you focus only on this, then you can take the next steps and try to know this tool. So probably data modeling, like we heard TypeScript before. React won't solve this all alone. So that's why maybe it's worth looking at this path from user interface, so from user interaction, what happens then in between until we get this effect on a page. If you build an application, this effect, I know, is changing a color, adding a product to a button, but something happens in between, and I would like to show you what exactly. So in order to do it, I will show you a few examples. Those will be pretty simple examples. But we'll show you just the main idea of the engine and what's happening. So we'll create a wish list. So now the wish list is pretty much empty. There's just some few words, and that's it. Yeah, let's extend it and make a possibility to make a wish. All you need to do to make a wish is add a button to make it. Yeah, and that's pretty much it. So you see maybe here also a few words. I'm using functional components. So I've heard recently that not all guys who code in React were able to switch from class components to functional. So I really hope in the near future everyone will be able to try it out. If you don't have possibilities on your current work, just play around in your free time. It's really, really awesome, but you really need to switch your mind. It's pretty much different and different problems out there. Further, we want our button to do something. With just clicking on it, we're incrementing the count of wishes we just made, and that's it. So that's the whole component. So what really React does for us, because this is the code we do write in our daily work, and that's it. Then the magic happens. So what's there? Let's check out if this all works. So this is the code here, and the result, hopefully, okay, it does make wishes, and that's it, no magic there. From user interaction, so clicking a button, you get a result here. A change of state makes a change in the output text here. Okay, so then probably this render happens. So this really the keyword that I wanted to really explain or show you the two meanings of it that probably are out there. So the first meaning is that probably that there is out there from this previous phase, that pre-React era, or that we know from browsers, the fact that the browser renders something, like here, like someone renders someone, or in different words, the actual DOM rendering part, so painting, layouting, and so on. And there's the different meaning in React. In class components, we even have this function called render. So this is the second meaning. So in fact, when the React core engine takes our code, then does a bunch of stuff, and we got some output. So I would really like to focus on this second meaning, so the React render part, because this is pretty much different. So the React render does not really do these updates for you. Just the second phase does. So in this process between the user interaction and the outcome, you got this render phase when React changes your code, compiles it, and so on, and the commit phase, which takes the result of this render phase, and then this commit phase does this update. So this is all possible through this huge concept called virtual DOM. This is something that appeared like with the very first version of React, and it was, wow, how can we speed up this DOM changes things. Let's take the DOM to memory and make changes there, then apply to the browser in a package, and this will make things fast. But this is more like a concept. So there's a a lot of different things that build this virtual DOM, but there's no actual, like, the whole structure of the page is kept somewhere exactly the same and then somehow differentiate. This is a bit more complex. So this is just an idea to abstract all those things that needs to be done, and then commit those updates. And with this abstraction, there's somewhere a possibility to optimize those. And the really nice idea there is to take this abstraction, this virtual DOM, and this doesn't really need to be DOM. So the part when the render works, so where then these calculations are made, and then the commit phase to what output we want to do it. These are two different things right now. So you might want to commit it to the browser, so then you use the library like React DOM, then to your native application, React Native. React VR I have not tried yet, but this also uses just a different output. The render phase stays the same. So yeah, how this render phase looks like. So this is called right now fiber reconciliation. And this is, you want to grab a coffee or take a deeper breath, because it's not that easy to understand. I will just try to show you like an overview and a rough picture how it looks. There's really a lot of cool talks, guys explaining for an hour or 7 hours how this works. And after watching those, at least I understood, so I'm pretty happy, but just I will maybe try to invite you to later study this more. So reconciliation. This is one of these buzzwords I showed you at the very beginning. This reconciliation, in a nutshell, this is this diffing algorithm that takes your application in a current state. You know that a new state is coming, and it calculates all the necessary things it needs to be done to move from one part to another. Last year's React Core members thought that there's a change needed, and this algorithm does not meet the expectations that are there now. So they rewrote a bunch of stuff, or the whole algorithm, and the current algorithm is called Fiber. This is the code name and also a name for a part of like a unit of work there, but it's there from React version 16, I believe. The previous algorithm didn't have a name. It was just called reconciliation. Now it's Fiber reconciliation algorithm. So in order to show you how this works, so how this new reconciliation algorithm makes this possible, I would show you again this example, wishlist. It's pretty much the same like it was. So what React does in the first place, it's this part is written in JSX, so it's pretty easy to write. It resembles the DOM or HTML we're used to, so it's very readable. We could write our code also like this, using React create element. This is in fact the code that you've seen before, just translated by React. So it does not operate on JS6 itself. It then first it takes your JS6 and transforms to understandable functions like this. So, but this we also could write. You still see some properties here, callbacks and so on. Then render function is called, and out of render we're getting this React element. This is a very simplified version of this wishlist component. I removed a lot of stuff. I wanted to just show you that still we see the types here, properties, and the main wrapper has 2 children. You see also the current state with the count 3, and that was the state until React 16. and that's it. Render happened, and then React just calculated a bunch of stuff and did the updates. Now with the fiber, there's additional layer on top of it. So this code that you see in here, this is created on every re-render. Every time your component re-renders, this is created from scratch. And in comparison, fiber nodes are created only once and reused then. So this is hopefully a bit more performance friendly. And there's also idea behind it. So one thing was to make this whole algorithm calculating this changes to add the possibility that it runs asynchronously. So in order to then in future introduce a new features to React, like suspense and maybe possibility to work in a multi-threaded environment later, so the work then can be splitted between multiple processes. And this algorithm provides that. Also the possibility to pause the work. So if the calculation is being done and it takes sometimes a lot of time, and there something happens, for example, in browsers, these are animations. You really want to have this fluid 60 frames per second animations. And React would sometimes need to pause the work in the definc, then trigger animation triggers, and then after the animation frame, it can continue the work for like 16 milliseconds. And they really achieved that here. So this is how, again, for this wishlist example, fiber node looks like. Still simplified, but you see it's very different from the React render output. So there's a bunch of other fiber nodes and a bunch of effects. I cannot tell you about all of them, but let's focus on 3. So how the nodes are connected, because at least for people coming from strictly front-end development, this DOM tree node is like natural thing. You have parents, you have children, and that's it. You're not aware that there's some other possibilities to structure your data in the world. So this is in fact it's the tree, but it's not like a simple tree. This is a singly linked list tree, and it works like this. So this is how for our wishlist fibers are connected. So there are 3 types of connection: a child connection, but each node can have only one child connection. So it connects to its first child, and then a child connects to its siblings, only to one sibling, and so on and so on. And each node has a return to its parent. So pretty neat. And it works like this, that if there's a change in state, so something changed, a button was clicked, the work begins at root, and each fiber starts its work. Then it finds out, okay, I have a child, I will pass the information to child to start its work, and so on until there's a fiber without a child. Then this fiber can say, okay, I can complete my work and pass the information to return node, and so on, until all informations are passed. So React takes the advantage here and uses a thing called request idle callback. So this is a really cool thing I was not aware of. So this is a function that tells you if there's an idle time in your main thread for a lower priority of work. And this React, since the version 16, takes advantage on it and does this definite algorithm during these phases. So when there's a phase that has a higher priority, like animation, this diffing is paused and continued later. Yeah, and now you may wonder what's end of this phase. So after all the work is done, there's a list of effects. So we have a list what effects needs to be done in order to really see the output of the new, changed state. And this is called then the commit phase. And in this commit phase, you see then the output in the browser, the whole updates. The difference is that this phase is synchronous. So you see the state of the application is really kept, and there won't be difference like part of the application did update, part not. Okay, so as I told you that React does a lot of calculations during this renders, that it transforms JSX to this create elements, then creates this whole new structure, this with types. It sounds like a lot of things to do, but yeah, in the end, it does a pretty good job doing it fast. So in normal life, you just don't care if your application re-renders every 20 milliseconds or not. But I believe you should still be aware when it does re-render, and if you see really a performance issue, what possibilities you have to fix those. So I will just show you a few examples of optimization possibilities that are out there for functional components mostly. But still, I advise you not to like starting from there and writing your code this way, just if you really see your application freezes or it's not fluid 60 frames per second animation, then you can see the possibilities. So first, React Memo and pure component. So you can say to React that this component does not need to re-render. Because in normal way, this algorithm goes from parent to child to siblings and re-renders all of it. But you can say, okay, this thing you don't need to touch. And you can do it by React Memo. And let's modify our example of wish list. Still, it's just a button. By adding some more things there that will cause re-renders. So I added a wish text that this is an input field, which as soon as you input something to this input text, you see the preview of your wish on a screen. And that's it. So I also added a thing like profiler wrapper. This will be used across examples also further, so let me maybe explain what it is. In React 6.9, they added, made possible to use for everyone this profiler thingy that accepts to properties ID of your part of a tree, and callback method called onRender, and this callback method is called whenever whenever this part in which you wrap this profiler gets re-rendered or mounted, updated. So every time you will get this callback function called, and it gives you a bunch of information like ID, which you put in your properties, phase in which this happens. So if it's mount on update, and lots of times. So how much time it took, when it started, when the commit phase was, and so on. So we'll use it to see when this updates or what components are updating. So this simple wish text component just has an input with onChange handler, And in progress, we just see like every character that we write. So let's see how many re-renders we are having now. So here you see 4 mount information. So because we have 4 components, there's this wish list, there's wish counter. This counter, it's the text here with currently 0. Wish text. Yeah, and wish preview, which you don't see now. So let me clear those now. Or no, not here. So as soon as I write anything here, I got 4 updates. So my wishes counter updated, which still says like you have currently 0 wishes, it still got re-rendered, which is not bad. It's it took like 0 milliseconds, but so like a fraction of millisecond. So you can imagine that in normal daily life you don't have to care about it. But still, if you have a very complex application, or because of your architecture there's a bunch of other things happening, you might not want to re-render this some component all of the time. If you just I don't know, put a character in text field. So we can wrap this our component in React memo. And React memo says to React, you don't have to re-render this component if there was no change in properties. But it does like this shallow comparison of these properties. So, for example, reference are compared. So if you pass an object as a property and your reference will change, this will anyway re-render. So it works for this plain variables, but you can add custom comparison function where you can put a lot of logic. So here it's not needed. Still count, it's maybe integer. We would know if you would use TypeScript, but I did not in this example. But still you could put there a lot more complex logic to then tell re-render or not to re-render. Nice to remember fact, if you're working like with both, maybe class components, functional components, here the comparison function tells like if these components are equal, and React pure component, this is something you extended in class components, there's this should update class, and there your implementation should say if it should update. So the opposite. The true would mean in the class component that it should re-render. So here there's example with, let me maybe show you text or even counter. I wrapped in React memo, and let me clear those mounts. And now as soon as I click something, we'll see just 2 updates of the components that really changed. Okay, so you might want to think, yeah, so let's put everywhere React memo, because yeah, why not? It's if there are equal, then yeah, there's no re-render. If not, yeah, re-render. Yeah, but this is like premature optimization, and this is probably always bad. So you might think of a case that your component updates like very frequently. Then if you would wrap it in React memo, your comparison function would like always return false. And just this would be just unnecessary call every time. Okay, then there's a bunch of hooks in functional components that you can use to also improve performance in some situations. Use memo hook. This is a hook that stores a value of your function until some property that you put as a second argument, there's an array of properties. Here I have just count. If any of property inside this array changes, then only it updates the value of your variable. So this is probably useful in situations when something re-renders and you cannot do anything about it, and you have a function that takes a lot of time to run. Then just use React Memo, and that's it. Example here, I've put, I decided to count a lot to 10 million, and because it will take a lot of time, I hope. This now happens on, I don't have, this function is run in my main application component, so it will anyway re-render. So this function is called on every click on my keyboard. So it takes a lot of time to re-render. Now here the time is still small. To be honest, I still don't know why. That's why there's another possibility to measure it. There are React DevTools. So I just recorded how long it takes according to React DevTools, and each click took like 2 seconds to re-render my application. And just by wrapping this in use memo, so you may see here the function stays the same, just the use memo that, and that's it. Then everything works pretty fast. Yet another hook. Above says use callback. Pretty much the same like use memo. Use memo you had for function that returns a value. Use callback stores like the whole function or reference to it. So unless again something in the second argument, the array of properties changes. So if we update our code to use some function. So I changed the button right now. A button is a separate component called make a wish, and I just pass this callback function here as its property, and then this function is called. So right now, although let me make a wish. I don't want this to re-render. I've put it in React Memo, so I expect it won't re-render, and it does. It just has a function and nothing else. But still, if I've just changed the value of the input, my button re-renders, and this is exactly because we're passing here a function that we create here. So use memo, use callback will help us with this. And here, clearing, so just 2 updates, and all the work here was to wrap it just with use callback hook. Another thing now, without example, use ref, it's not strictly connected with memoizing things. Sometimes you might want to store some variable in React, but and change its value, but avoid re-renders. So using useRef hook and changing value of the current property created with this hook won't cause re-renders. This I consider even a bug. So using object literals, back, because it's so easy avoidable. The previous parts, you had to add additional layer of logic. You had to add hooks. This is additional complexity. And with object literals used in JS6, you to avoid this issues, you don't have to add additional layer of complexity. This type of thing, so just placing any property, but creating the object, in fact, inline here, it causes on every render a new object will be created, and with that, all the things we did to avoid re-renders are gone. Sorry. Yeah, to avoid re-renders here, just create your objects outside of your functions. So just moving up and creating this object once saves the day. And yeah, this is how it works. Okay. Yeah, this time it showed. Yeah. Anything here? Okay, so 3 re-renders, and as soon as I move the style outside, so as soon as this is moved outside, the re-renders are gone. So this is just like a code cleanup. Okay, so I told you that before, but I really want to emphasize this. Yeah, do not rewrite all the code right now. Yeah, now maybe to functional components, that's okay, but not to really optimize right now everything, because yeah, let's now console log everything. Okay, this renders this, let's change it. No, you just, if you have problem, then sure, but you can maybe even cause your application to run slower. A bunch of tools to help you in optimizing. So there's React DevTools, of course. Right now upgraded to a new version. There's, if it's not enough, there's also a Chrome, probably Firefox also. DevTools to really profile the performance, check what are the problems there. There's a bunch of nice tutorials there. Yeah. Okay, and a short summary. Yeah, this was about React, but what I would like to emphasize, like, know your tools. So take your time, study a bit, try it out even. Yeah, I'm using here Code Sandbox, and after that you can really jump into projects. And be cautious with premature optimizations. So yeah, I learned a lot from these few blog posts. You can check them out also. And yeah, thank you.
Questions? Okay.
Hello.
Hi.
So I've got a question regarding use memo. So we said that if you don't pass this array of dependencies, then it will do the job anyway. So how does it work? Does it do this shallow comparison for all the arguments to this function that is wrapped with use memo, or how does it work?
Yeah, let me maybe. Yeah, it does shallow comparison of all properties. So if you have like 10 properties, it will automatically check each one of the properties, and that's it. So this you get by default, and yeah, probably if you need to really deeply check a lot of things, you might want to think, okay, is it really what I want to do or not? So yes, exactly.
Okay, thank you.
Next questions?
Behind you.
Hi. Any advice on how to approach the optimization? Because like the object literal that is created in render and can be extracted outside of the component, it seems like a pretty good and straightforward example. And this can be pointed out at code review or the code written or maybe some SDN rule, but not everything is that trivial. So. What is your approach basically to finding out those bottlenecks or optimizations and those kind of things? Because this is what interests me.
Yeah.
Thanks.
So if I have performance issues, but which I don't. No, sorry. Seriously, yeah, I start from yeah, maybe stupid way, but console logging, debugging right now with this profiler I used in my last project a week ago to discover a performance issue, just to see if to have a rough feeling, like okay, it's my navigation, and there's so this would be a first step, and to find out if this is some computational problem, like you really are, for example, having an array that you're getting from a backend, and it's for some reason, I know, 100,000 elements, and you then trigger a map. So to really narrow down the topic, I go just from component to component, like pretty dumb way, but works. And in an hour, I usually have my answer. I also, when I had a really serious issue which I couldn't find in like an hour of trying out things, I used this Chrome DevTools. So this then takes a bit of time, especially at the first time, to study a bit. I haven't used the latest ones. Now there are really they have more even more possibilities. But then it took like a day, and I got the issue, the problem. So the Chrome DevTools can even take advantage of your source maps of your code and tell you which function run for how long and so on. But I have not tried this with the source maps. I just read it here. Before, like a year or two ago, this was just still a bit of guessing. The sources were there, but without source maps, I had some issues to really discover exact problem. So pretty much here, I would start.